All right, so just like we did on the other graph, and if you're watching this, make sure you're filling in the graph on your own. Okay, so we label our time in seconds, and over here we have our position in meters, and I know that because I have position, and I have meters, and I have time, and I have seconds. So all of that is going to be our labels and our units, which is always super important. Now I have to decide what each space is worth over here, what to make it, and I go from 0 to 50. So again, like we did before, ones, we don't have enough room, twos, we don't have enough room, fives, we don't have enough room. But if we count by tens, we can fit all of our data. We can get up to 50 meters. And then time, this time I'm going to make it worth every other space. So each space is actually a half a second. So 1, skip, 2, skip, 3, skip, 4, and there's 5. Okay, just so you can see how when you spread things out, you make your spaces worth a smaller value, it actually makes your graph bigger. So at 1 second, I went 2 meters. So 0 to 10, like I have to be pretty close to the bottom here. Obviously, it's not perfect because it'd be nice if these graphs had more lines on them, so we could be a little bit more precise, but it's okay just for practice. 2 seconds, I go 8 meters, so I'm getting a lot closer to my 10, still not quite there yet. 18 for my 3 seconds, so just below my 20 would be a good spot. 4 and 32, so I'm going to be just above my 30 line. And for 5, it's at 50, which is up here. And notice how I'm using my finger and like connecting like to get over there, right? So it could be something like this. Again, this is a curved line. It is a changing velocity. So if I look here and quickly do my velocities, I get 2 meters per second here. Here I have 8 for my position over 2, which is now 4 meters per second. This one is my position over time again, but now I'm at 6 meters per second. 32 and 4 gives me 8 meters per second. And again, I'm just doing this to prove it to you. It's not like you would need to do this on a graph. But you can see it's increasing by 2 meters per second as it continues its path or its motion, speeding up. Okay, so those are basically the 2 types of graphs you'll see, constant or changing. So now we're just going to take a look and do some practice here. All right, so it says below is a graph of a ball's motion. Which of the following gives the best interpretation of that motion? So remember what we said about a flat line. If a person who is hooked up to an EKG monitor has a flat line, we agreed that that meant that they were not able to move because they were deceased at that point, right? EKG monitor is flat line, meaning they can't move. Same thing here. If we have a flat line on our position versus time graph, that means that there is no motion. So if you look here, it's like at 5 meters away from the origin. So if it's traveling at 5, 5, 5, 5, it's not going farther away from the origin, and it's not getting closer to the origin. So that means it's stuck 5 meters away from the starting spot. All right, so anytime you see this flat horizontal line, that is letting you know that the object is not moving. Okay, so if I am 5 meters from the door right now, I'm not moving closer to the door, and I'm not moving farther from the door. Time has to keep ticking and passing by, but I'm not changing my position. All right, so even though I'm 5 meters away, I'm just staying at that 5 meters from my door or the origin or the beginning. All right, so I'm at 5 meters for almost 5 seconds. Okay, so take a look here. See which one of these you think looks like the best answer that matches that graph. read through those choices. All right, and so this is our first kind of time with this practicing. So what do you think? What, anybody like option A? Okay. Does anybody like option B? Got a couple? Anybody like option C? Anybody like option D? A couple of you might have voted twice. It's okay, maybe change your mind. All right, so our answer is actually D, which is what the majority of you said. The reasoning why, so A, sometimes people think that the graph is going to show the motion, and this is what it says. Rolls along a flat surface, then moves downhill, and then stops. The graph doesn't show the pathway. You have to think about what's really happening here. I like B because it says it doesn't move at first. The problem with B, what made it wrong? What part of this answer made it not correct, Cade?
Moving forward and not backward.
Good. If this had gone uphill, like showing a positive slope, then B would have been correct. But because it says forward, that makes it incorrect for this. Nobody liked constant velocity, so that was a good one to be able to rule out. The ball doesn't move at first, then it moves backwards, and finally stops. All right, so doesn't move, moving backwards, and then the flat line again means it stops again. Okay? All right, so we'll go ahead and we'll probably have to stop there.